So look at first question. The question is, a satellite of the mass ms is in a circular orbit of the radius x about the Earth. The Earth may be considered to be an isolated uniform sphere with its mass m concentrated at its center. Show that the kinetic energy of the satellite is given by the expression. So 3 marks. So first of all, we have to derive the equation for the speed in orbit. Centripetal force is provided by the gravitational force. Centripetal force is mv square over r, but x. And the gravitational is g capital M small m divided by x square. Now this small m cancelled, 1x cancelled. So the speed square is equal to gm over x in the orbit. And kinetic energy is equal to 1 by 2 mv square, 1 by 2 m, and the v square is gm over x. Hence, kinetic energy is g capital M small m over 2x. So it is proved. So first we have to write that the gravitational force is providing the centripetal force. We have to derive the expression for the speed in the orbit, and then kinetic energy half mv squared. So this is the answer. The next is state an expression in terms of g, m, ms, and x for the potential energy. So this potential energy in the orbit is minus g capital M small m over x. This is the expression. So we have to state it. No need to explain it. So definitely this small m is ms. And the next, using the answer, derive the expression for the total energy. So the total energy is the sum of kinetic energy and potential energy. Okay, now the next, use the answer form, derive the expression for the total energy. So total energy is the sum of kinetic energy plus potential energy. And the kinetic energy we have derived here, it is gmm over 2x, g capital M small m over 2x, and plus this paper. And the potential energy is equal to minus g capital M small m over x. So what is the common? Common is g capital M small m over x. So 1 by 2 minus 1. So the answer is minus g capital M small m over 2x. This is the total energy. Now move to the next question. A small resistive force acting on the satellite caused the radius of its circular orbit to change. Use the answer to state for the satellite whether each of the following quantities increases, decreases, or remains constant. Due to the resistive forces, there will be the loss of energy. So definitely the total energy decreases due to the loss of energy. When total energy decreases, radius of the orbit also decreases. Do remember, look, the total energy E is equal to minus G capital M small m over 2x. So look, when this negative sign is quoted, it means E and X both are directly proportional. because this negative sign is making inversely proportional to directly proportional. So when this E is decreasing, X is decreasing, so orbit decreasing. Now the potential energy also decreasing due to smaller radius, but the kinetic energy increases. Reason, because the speed is equal to gm over r under root. When r decreases, speed increases in the orbit. Decreases, 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 and increases. Move to the next one. The question is state what is meant by an ideal gas. A gas which obeys all gas laws, PV is equal to nRT for all values of pressure, volume, and temperature is called an ideal gas. So this is the only definition. A gas which obeys all gas laws, PV is equal to nRT for all values of pressure, volume, and temperature is called an ideal gas. Next, the mean square speed of the atom of the fixed mass of the ideal gas at 32 degrees Celsius is 1.9 10 power 6. The gas is heated at the constant volume to a temperature of 80. Determine the rise in Kelvin of the temperature of the gas. Simple. 80 minus 32. What is the answer? 48. This is 48, right? So do remember, change in degrees Celsius, exactly change in Kelvin. So it is 48 Kelvin. The other method, first convert this 80 into Kelvin, 32 into Kelvin, then take the difference, right? So we'll get the same answer, 48. Next is the root mean square speed of the atom at 80. So look, Vrms is directly proportional to temperature under root, because 1 of 2 mv square half is 3 by 2 kT. So mean square speed directly proportional to temperature. So RMS speed directly proportional to temperature under root. So we can write here Vrms1 divided by Vrms2 is equal to T1 over T2 under root. So first RMS speed is 1.9 into 10 power 6. So 1.9 into 10 power 6 divided by required. First temperature is 32 plus 273 divided by 80 plus 273 under root. Now simplify it. It is 1480, approximately 1500. 1480 meter per second. And the next is state an expression in terms of the work done and the heating that is used to calculate the increase in internal energy of the system. So we will write here, according to first law of thermodynamics, heat energy supplied is equal to increase in internal energy plus work done by the system. So plus Q plus U minus W mean U is equal to Q plus W. because the work done by the gas is represented by minus W. Increase internal energy plus U and heat supplied plus Q, but internal energy is equal to Q plus W, mean heating, heat supplied plus work done on the gas. State and explain in terms of your expression is A, the change, if any, in the internal energy of the water as ice cube. When the ice melts at atmospheric pressure to form a liquid without any change of the temperature. If there is no change in temperature, there is no change in kinetic energy. So first we have to write due to constant temperature, no change in kinetic energy. Look, when the water of water in an ice cube, when ice melts, do remember when ice melts, the volume of the water decreases and the density increases. When water becomes ice, it expands, volume increases, density decreases. But when ice melts, density increases, volume decreases. So due to decrease in volume, work is done on the water, on the molecules. Thus, internal energy increases because the work is done on the gas, on the molecules. Next, state and explain in terms of your expression the change, if any, in the internal energy of the gas in the tire when the tire bursts so that the gas suddenly increases in volume. Assume that the gas is ideal. So ideal gas. So due to expansion of gas, work is done by the gas. Hence, decrease in internal energy. Hence, decrease in internal energy. And the work is done by the gas, where against atmospheric pressure. This is important, bigger 3 marks. Next, whether there are any frictional forces acting on the trolley. Yes, because resonance graph has well-defined peak. Look, this peak here is the rate of gain of energy is equal to rate of loss of energy. So definitely when there's a loss, it means there is a forces, resistive forces. फिर ये ऐसा ग्राफ होता है undefined peak. Oscillator in B now stopped. The trolley is given a horizontal displacement of 4.7 centimeter along the line of the spring. The trolley is then released. Use the information to estimate the maximum frequency of the maximum speed of the trolley. So maximum speed formula. E max is equal to x naught omega. And x naught omega is equal to 2 pi f. What is the x naught? X naught is 4.57 centimeter, mean 4.7 10 power minus 2 into 2 into 22 by 7. And the frequency, what is the value of the frequency? 2.1. Answer. (0.62 meter per second). This is the maximum. Next, last question, Ajka. A charged particle P is situated in a vacuum at distance of x from the center of the charge conducting sphere of the radius r. For a particle P outside the conducting sphere, the charge on the sphere may be assumed to be a point charge at its center. State Coulomb's law. Electrostatic force is directly proportional to product of 2 point charges and inversely proportional to square of the distance from their centers. Electrostatic force is directly proportional to product of 2 point charges and inversely proportional to square of their separation or square of distance from their centers. The sphere and the particle P are both charged positively. Both are positively charged. State the direction of the force acting on the particle P. Definitely due to repulsion, it will move in this direction. So the direction of the force is towards the right. Towards right at P. State the position of the particle for the maximum force. The maximum force, look, F force is equal to EQ. F is equal to EQ. So charge is constant. So the maximum force is there where E is maximum, and E is always maximum at the surface of the charged sphere. So we will write here at the surface of charged sphere. When the P is placed at the surface of the charged sphere, it will experience the maximum force. Determine the ratio. Force on the particle P at R and the force at the particle X and Q. Force, look, it is equal to K Q1 Q2 over R square divided by K Q1 Q2 over 4 R square. Because the force formula, Coulomb's law, it can be written as 1 over R square over 1 over 16 R square, because this cancel with this. So we can write it 1 over R square multiplied by 16 R square cancel. The answer is 16. Formula of the force is F is equal to 1 over 4 pi epsilon naught Q1 Q2 over D square from this. And the next is, when the charge on the sphere is 6 into 10 power minus 7, the electric field strength at the surface of the sphere is 1.5 10 power 6. Electric breakdown occurs when the electric field strength at the surface of the sphere exceeds 2 into 10 power 6. Determine the additional charge that may be added to the sphere before breakdown occurs. So electric field strength, E is equal to 1 over 4 pi epsilon naught Q divided by D square. So E and Q both are directly proportional, is it? So we can write E directly proportional to Q. So E1 over E2 is equal to Q1 over Q2. Initially, the E is 1.5 into 10 power 6, and the later, the E is 2 into 10 power 6. Initially, the charge is 6 into 10 power minus 7, and the next charge is required. So this X becomes 8 into 10 power minus 7 coulomb. So what is the additional charge? Delta Q, 8 into 10 power minus 7 minus 6 into 10 power minus 7. So the additional charge is 2.0 into 10 power minus 7. Because the question is calculate the additional charge, which is added, the difference of both.